Welcome to lesson 7.7 for honors geometry. So today we're going to learn about how to solve right triangles. So we've learned a lot about trig over the last week or so. Now we're going to learn actually how to solve right triangles. So what does it mean to actually solve a right triangle? To solve a triangle means that you know all of the angle measures and all of the side lengths. So we have the right triangle below, triangle ABC. And in order to solve this, if we have two side lengths, or one side length and one acute angle measure, we can solve the right triangle. We have enough information. So what this is saying, if we take a look at our triangle ABC, is that if we have any two side lengths, so for example, we have side length AB and BC, or maybe we have side length AB and AC, or lastly, we have side length BC and AC, we can use that information and solve for the triangle. Or if we have one side length, such as BC or AC or AB, and one acute angle measure, so either angle A or angle B, then we can also solve for a right triangle. And we're going to use the trig functions that we've learned thus far, and we're going to introduce the inverses of these trig functions as well, because we'll need those to solve. So moving on to the next slide, inverse trig ratios. An inverse function is a function that lets you solve for the angle measure instead of the side length. So remember when we solved for tangent. So if we had tangent of angle A, so over here we had our angle measure A, we could plug in the angle measure and it would give us the ratio of BC and AC. So what happens if instead we have this ratio BC and AC and we want to solve for the angle? Well, we can do that. And the way that we do that is use the inverse function. You'll find this function on your calculator if you press second tangent. So tangent inverse, or the inverse of tangent, of opposite over adjacent. So like we've got here, BC over AC will give you the measure of angle A. That's what the inverse function does. Likewise, remember sine is opposite side over your hypotenuse. So if in fact we have the opposite side and our hypotenuse length, then we can use the inverse function having those ratios, so opposite over hypotenuse, and that will also give us the measure of angle A. And lastly, we can also use cosine. So remember, cosine is adjacent over your hypotenuse, inverse cosine, so you're going to use your ratio adjacent over hypotenuse, and that will also give you the measure of angle A. And conversely, you can do these all for measure angle B too. You just have to make sure that you have the right ratio set up. So with that, now we're going to go into some examples. And let's go ahead and clear off those marks. So now we're going to learn how to actually solve the triangles. So in our first example, we've got angle A is 40 degrees. So let's go ahead and mark that. And we know side length AB is 8. So we need to solve for everything else. So we need to find BC, we need to find AC, and we need to find angle B. Well, we can actually solve for angle B without any trig. We know that angle C is 90 degrees, angle A is 40 degrees, so we know there's only 180 degrees in a triangle, so the measure of angle B equals 180 minus 90 minus 40. So the measure of angle B is 50 degrees. So we've already solved for all the angles now of the triangle. But now we need to solve for the other side lengths, and we're going to use our trig functions for that. We can use either sine or cosine. I'm going to use sine of angle A and set up my ratio. So if I do sine of angle A, which is 40 degrees, we know that that equals opposite side, which will be BC, over our hypotenuse, which is 8. So in order to solve for BC, we're just going to do algebra, and we get BC equals 8 times sine of 40 degrees. So when you put that into your calculator, you end up with BC equals 5.14. So now that we have BC, let's go ahead and mark that. We're going to now solve for AC, and I'm going to use cosine. You could also use sine. You could use sine of angle B, but I'm going to use cosine of angle A to solve here. So cosine of 40 degrees is equal to the ratio of the adjacent side, which is AC, over our hypotenuse, which is 8. So again, using algebra, we'll get AC equals 8 times cosine of 40 degrees. So when you plug that into your calculator, you get that the side length equals 6.13. Now, it's always good habit to take a look at your triangle and see if that makes sense. We know angle C is our largest angle. It's 90 degrees. And 8, which is the side opposite of it, is the largest side. So that's a good thing. Now taking a look, angle 40 is our smallest angle, and 5.14 is our smallest side. So that makes sense as well. And lastly, angle 50 is the middle angle, and 6.13 is between 8 and 5.14. So that looks like we've done it right. It's just kind of a good check. Okay, so now let's clear this off and solve the next example. So here we're given all of the side lengths. So we have BC is 3, AB is 5, and AC is 4. So this is actually one of our common Pythagorean triples, but we need to figure out what is the angle measure of A and B. So in order to do that, we're going to use our inverse functions. So the first thing that we're going to do is we can set up sine inverse of A. So remember, the inverse of sine means that you're going to plug in your ratio. So sine is opposite, which would be BC, which equals 3, over your hypotenuse, which is 5. So this is what you're going to plug into your calculator. So make sure that you do second sine, and then type in 3 divided by 5, and you're going to get the angle measure of A, which equals 36.9 degrees. So now that we have measure of angle A, we already know that C is 90 degrees. So we don't need to use any more trig to solve this. We're good. We just have to subtract our angles off to get measure of angle B. So angle B is going to equal 180 minus 90 minus 36.9. And when you type that into your calculator, you get that the measure of angle B equals 53.1 degrees. So we've now solved this triangle. We have all 3 side lengths and all 3 angle measures, and we're done. So this is an extremely short lesson. That's it for today. I hope you guys enjoyed it and look forward to seeing you in class. Have a good one. Bye-bye.